So we're going to talk about Chem 103, which is the lab section associated with Chem 101. And we'll start with sharing the syllabus here. Oh, is everybody side-by-side screen? I don't know if you had time to make that adjustment yet. There we go. So put that one down. Let's see, stick this one over out of the way. Okay, so there's the syllabus. There's a striking resemblance to the other one. We just changed the numbers. Contact information the same. We need to look at materials that you're going to need. There's no textbook, and you probably already know that if you've been to the bookstore. All the lab exercises are delivered in Blackboard, and I'll show you where those are in a little bit. Calculator, that's old news. These materials, you will need a bound lab notebook that is quadrilined. That is, it's lined in such a way that you can draw graphs in it. And let's see, do I have one? I think I might have one. Yeah. I got a picture of the cover of one right here. And then here's the touchy-feely one. And it's got the graph paper. It's built like graph paper. And the reasons are obvious. I want the quadriline because if you ever keep a lab notebook for an employer, it's going to be that type. When I worked for the federal government, they were even worse than that. They had these lab notebooks that were made for the government, and they had ugly green covers, and they were bigger than this. They were like down about there, and we couldn't use anything else. It had to be that kind, which is fine because they paid for them. But these guys are not very expensive. They're 95 cents at Walmart. And if we were face-to-face, if we were able to do this class face-to-face, I would have a stack of them, and I would just sell them to you for $1, just to recover my investment. And even with tax, that wouldn't be complete. Tax would be what, $1.01, just so I don't have to make change. But unfortunately, you got to go out and look for them. And I found them at Walmart. I haven't looked other places. You can probably find them at Staples, but they're going to be very expensive at Staples. They're like $3 or $4. That's just the way Staples is. I'll show you what to do with them in a few minutes. The other stuff is optional. If we were going to be in the lab, you would have to have a lab coat, right? If you're going to take any more lab courses, and you hope to be face-to-face eventually, you may want to start looking around for a lab coat. And they usually require knee length at least. And of course, if you're in the lab, you need to protect yourself, and not just the lab coat. The gloving that you might need is provided if you were in the lab. We have eyewear, but it's usually scratched up, so you probably get a pair of those for yourself. And then your legs need to be covered, and your shoes need to be completely enclosed. No sandals, no open-toed shoes. Those are just requirements for working in the lab. But the only required material other than the calculator is this lab notebook. And I'll give you instructions on how to prepare it in a few minutes. Learning outcomes, just like before, outline just like before. How are the exercises delivered in Blackboard as PDF files? And I'll show you where those are located. You'll always have the hard copy document for the exercise, and there will always be a video associated with it. Optionally, sometimes we'll have a document with the data included. Otherwise, you have to glean the data from the video because we can't do it. This is all virtual. So what I've done is I've created videos. The first one I think I did here in my office because it doesn't require any lab space. But the rest of them, the other, let's see how many we have, 7, the other 6 are recorded in a lab space. So you can see the environment and watch me perform the lab. So you have to be very observant, and if at all possible, put yourself in my place. What would you be doing now if you were there? There may be supplemental documents. Sometimes I create documents that explain how to how to treat the data once you get it. Once you've completed the exercise and you got the information, what do you do with it? It's not always obvious in the printed method how to do that. So if I think it would be valuable, I create these extra documents that help walk you through the process. There may be 1 or 2, I can't remember, that have open source videos. And if those are, most of them are copyrighted, I'll present them in such a way that I give credit to the source. Okay. So this is, okay. Something that I've done different this semester than last semester. Last semester, I was really lenient with the class. I just removed all the deadlines because they sprung this COVID thing on us. So I said, okay, no deadlines. Well, that backfired because what students did was they procrastinated. And they ran right up to the end of the semester and were just scrambling to get their work in. So this semester, the lab will not be available until, well, I should say, the video of the lab will not be available until you take the hard copy of the exercise and enter the information into your lab notebook in preparation for the lab. And then you photograph or scan the pages of your lab notebook that apply to that lab and submit them as an exercise, just like we showed you earlier with the other documents that you complete and submit. And once I get those and look at them and grade them, and I put a grade into the grade book, once Blackboard sees that grade, then it will open up the video and you can proceed with the lab. But that way I hope will encourage students not to procrastinate. But this next section, this is what I want to see in your lab notebook. Perhaps before I do that, I should describe, I don't have the description in here, it's in Blackboard. What I want you to do to prepare your lab notebook is on the front cover, and this is all in ink, it's always in ink. Your name, the course name and number, like CHEM103. You can write out the whole name if you want, but you don't have to. CHEM103, the semester, and you may even put the start date or start end date. When I used to do those ugly green books for the government, there would be a place on the cover that would say start date and then end date. That is, Once you get it filled up, what's the date on the last thing you put in there, right? So you can tell what's going on. But those are minimum bits of information. Then the next thing you do is you go in and you start on this page, upper right-hand corner, with your ink pen, 1. Next page, facing the other direction, 2, 3. So all the right-hand pages will be odd numbers. All the left-hand pages will be even numbers. And you number the thing all the way to the end. And I think the last page will be 200. So if you end up with more than 200 or less than 200, you probably made a boo-boo somewhere. Okay, once you get all those pages numbered, then on the first numbered page, you create a table of contents. Just write it across the top in big bold letters, table of contents. And each time you enter an experiment into your lab notebook, you come back here and you say, what's the title and the page that it starts on. So you could put page up here, underline, and then just numbers down here beside each one. And one page should be enough. We're only going to do 7 labs. And then you could skip. You could either start on the next page 3, or you could even go to page 5. When you get ready to do your first lab, then you put your title, and that's what this stuff is for right here. That tells you what I want to see here relative to each of the lab exercises that you scan or photograph and show me, so that you can have access to the video. Okay? But once you've got the table of contents done, after doing all that other stuff, then I want you to scan or photograph this page, table of contents, some page in the middle, so I can see the number, and then the last page, so I can see the number. And that's the one that you will submit as the first notebook check. That's just to see that you've got it set up and ready to go. Okay? Then for each experiment, I'll want to see these things starting on the first page that you identify in the table of contents for the exercise. Write the exercise title. And then a brief introduction. Try to put it in your own words. What's this experiment about? I mean, what is it supposed to accomplish? Are there any actually hypotheses that you're testing? I mean, are you saying this happens, if I do this, then I get this result? Well, maybe you don't get that result when you run the experiment. But an introduction to let whoever reads it know what's coming. And I might say that when you create a lab notebook like this for an employer, the lab notebook belongs to the employer. It doesn't belong to you. So you need to write it in such a way that if somebody comes along behind you and looks at your work, they can duplicate it, or they see where the mistakes were. By the way, what if you make a mistake in a lab notebook where you're writing it in ink? You know, you can't go in and erase it. That's the whole purpose of writing in ink. So what do? Well, if you make a mistake in your method, or if, well, let's just say you do make a mistake. You put the instructions in wrong, draw a line through them, and then underneath, write the correct one. Right? So what does that mean? That means when you fill out this notebook, you need to leave spaces between the lines, right? Every other line at least, maybe every other second line, you actually write, and you leave space for corrections. And when you're writing in here, only write on the right-hand side when you're setting the experiment up. Right here, if you need another page, go to the next right-hand page. Now, why would you do that? So that if you make a mistake that's huge, you don't have to go to a following page. You just go over here and put it in, and then you draw an arrow to it. Okay? You can put other stuff over here, like if you want to draw a graph and you don't have room for it here, next to the data that it refers to, put it over here. The whole purpose of a lab notebook, well, actually there are several purposes. One is, if you're still with the company, then you want to be able to go back at some point in time, read your method, and duplicate it. If you can't duplicate it from what you've got in your lab notebook, you don't have enough information, right? You should always be asking yourself that question: do I have enough? Can I come back and do it again using this only? Okay. Can I see where the mistakes are? Well, yeah, if you just draw a line through it, you can read under the line and you can see where the mistake was. And like I said before, you want others to be able to duplicate your work as well, to check it, right? If a company's multi-million-dollar investment depends on the work that you put in this lab notebook, you want to be sure it's accurate. It doesn't have to be pretty, but it does need to be accurate. And thirdly, once you've put it in here and you've witnessed the experiment and you've made notes where I may have made changes in the method, right, that are slightly different than are in the printed method. So you'll make notes here as you watch the video that this, oh, he changed that, right? So you cross through it, write it in. You'll see observations of what I did, or maybe I make note of something, like I saw something happen, like we see a precipitate form, something, the solution got cloudy, or it changed color, or I ran an experiment and it generated these values, these measurements. They go in there. If you've got everything in here, it's complete, then you can write the formal report with this. You don't have to look at the hard copy. You got the formal report right here. You just use the right format, and we'll talk about that later too. Let's see. Okay. So what am I looking for when you send me those scanned pages? In order to open up the video for you, we need the exercise title, you need an introduction, you need to make a statement about safety concerns. If you were in the lab, what would you be mindful of before going in? And besides, the #1 safety measure that you take before you go into a lab is you know what you're going to do before you walk in the door. You don't walk into a lab blind, dumb and stupid. You walk into the lab knowing what you want to accomplish, knowing what the experiment is about. That means you study the experiment, and that's why creating the experiment in the lab notebook drills it into your mind. These safety concerns are important because you could injure yourself, you could injure your neighbor, you could burn down the building or blow it up, right? I know how to blow up a building, right? All I do is take a big old chunk of butter, put it in a beaker, and pour perchloric acid over it, put it on the hot plate under the hood, turn it on high, pull the sash down, and evacuate the building. Because sooner or later, it's going to blow. So knowing those types of dangers, you know, are important. And that's what the safety concerns are for. Okay, then what materials are required? Right? What do you need? What chemicals do you need? What utensils are you going to need? What special equipment may you need, like a pH meter or a spectrophotometer? Or do you need a ring stand with a burette clamp and burette to go in it? Do you need distilled water to wash things out or dilute something? All these things go into the materials required. And then you put your procedure in, step by step. Say, do this, do this, do this, do this. In numbered order. Okay? Then what are you going to get from that procedure? Well, you're going to get what we call data or observations. Now, the best way to set up your notebook for that type of information is once you get past the procedure, you've got a page here and you say, okay, I know I'm going to get numbers. In fact, lots of numbers. And they're going to be organized a certain way. Sometimes the hard copy will give you suggestions. It'll show you a table. It'll have a table built. Well, you don't put the values in that document. You put them in here. And the best way to know that you've got the information that you came for is to create a place for it in your lab notebook. Say, it may be as simple as this. Color of something, step 1. And then you got draw a line over here. That needs to have something in it. Okay? Or you create a table. And then down that table, you say, okay, at this time, say we're timing an experiment. It goes 0 seconds, 10 seconds, 20 seconds, 30 seconds, down here. Then this one is blank with spaces. I'm supposed to put numbers there. Now, why would I be so particular? Well, if you're running the experiment and you look down and you're down here doing something and you look up there, empty space, you might have missed something, right? So it ought to go back and look. Did I miss something? Or was that on purpose? If it was on purpose and you didn't have any data to put in there, then just put an X through it, carry on. But if you are missing data, you got to decide, is it the type of data that I have to stop and go back and start all over again? Or is it something that, that I can fill in, that I just forgot to fill in? So that's how you create space for your data. And it helps you organize your activities. Okay, then you'll have a section where you might have to do calculations, right? So you can do those here, set up a space for calculations and show that. And then there may be pre-lab questions. In fact, you can put the pre-lab questions anywhere you want. You could put those before the procedure if you want. But there needs to be a space for the pre-lab questions. And I know it's tedious, but you should write the question and then the answer. Or, well, hold that or for a second. There may be post-lab questions as well. So you need a space for the post-lab questions. Now, one thing you can do, and this is perfectly valid to do it this way, is if something doesn't need to be in your words, like you have a question and it needs to go in there so you can answer it. Well, you can print the document, cut it out, paste it in, and then write your answer underneath. Now, when you paste anything in your lab notebook, you need to take precautions because the glue may get old over time and the thing just falls out. Or somebody might come in and rip it out. You know, that's been known to happen in chemistry labs where the professor was grading on a curve and somebody that was not too bright wanted to destroy the curve. So he would pick out the smartest kids in the room and he would go mess with their stuff, right? So they wouldn't do as well. Well, if you paste something in here, what you do is, let's see, yeah, it's on the video. Say you've got, say I pasted that in my notebook, okay? So it's laying down. So what I do is I initial or sign it across the boundary like that. So it's part on the pasty and part on the notebook. Then at least I know if it falls out or somebody steals it, something's missing. I mean, that may not recover what you put in there, but at least you'll know. Okay, questions, pre-lab, post-lab. Let's see, what else was I going to do? I had something or that I was going to, data, observations, calculations, pre-lab. Okay, maybe it'll come to me. And then you want to put a section in there for discussion. Now, this can just be reserved space because you haven't done the experiment yet or watched it. So there's really no discussion. The data section, it won't have any information in it either, except you'll have a place for it, right? So when you scan those and send them to me, I'm not expecting to see anything in the data. I'm only expecting to see the title, the introduction, safety, materials, procedure, space for the data, space for the calculation, space for the post-lab questions. Pre-lab questions, yeah. Pre-lab questions need to be done before you submit your work because those come before you even look at the experiment. They're there to test, to get you ready for the experiment. Now, every experiment won't have pre-lab questions. Some of them do, so just keep an eye out for the pre-lab questions. If it just says questions, and it doesn't say pre-lab, then you can hold those till after. Only if it says pre-lab, those go in first when you submit that first scan, okay? And then a section for discussion. Now, why are we putting it in there this way? Because this structure mimics the structure of your report. Okay, so your report will look like this. It'll be similar to that. And in Blackboard, I'll show you where that is. I have given you a sample report. I picked out one from a former student who did an exceptional job, or nearly perfect, and gave me permission to use it in this fashion. And I just blanked out all personal identifiable information. So all you have is the report and maybe a filler like student's name. I might put, instead of the actual student's name, I just covered it up with student name. And you'll see how our report is structured. And it follows this similar pattern. Okay. The only major difference is that in the procedure for your report, you don't say, next do this, do this, do this. In the report, you're writing in the past tense. You're saying, this is what was done. That's what your report says. This is what was done. Now these are the results. So you have to use the proper tense for writing the procedure. So you would say something like, approximately 9.5 grams of such and such compound was weighed on an analytical balance. Rather than, if it was the procedure in your notebook, you would say, do this, weigh approximately 9.5 grams, blah, blah, blah. Okay, see the difference? You're talking in the past when you write your report. You're talking in the present or the future when you're writing it in your notebook. Okay, and I'll also include with that sample report a rubric, a grading rubric. Everybody knows what a rubric is, right? These are the things I'm looking for, and if you're perfect, you get this many points. If you're not so perfect, you get this many, and less perfect gets many. If you just blew it off, you get 0. All right, so it's a grid, and that's how I use to quantify your grading, so that you can understand what I'm looking for, where you went wrong, relative to what I'm expecting. Okay, that'll come later. When we get into Blackboard, I'll show you that, assuming I don't talk too long. Okay, there are a couple of reports that are informal, right? They don't take this formal format. The reason for that is they just don't lend themselves well to formal reporting, but I still want you to put the information in your lab notebook and record it there. Then you take the hard copy of the procedure, and it's set up so that you can fill in answers, and short answers or data, calculations, whatever, you can put it on that report. Then you would scan or photograph that report and submit that. And I've identified those in the schedule, and that's coming up next, which one of those are informal, which ones are formal, right? So there's no mistake. In fact, I've identified them here. The first and second one are informal. Everything after that is formal. Okay, so let's see. This tells you what your grade is based on. It looks better in a table, actually. Here, lab reports are worth 70%, right? Both formal and informal. I have to make a value judgment on lab skills, so that's kind of ethereal. I don't hammer anybody on lab skills. If you give me your reports on time, and I don't think that you would be a hazard in the lab, then I give you pretty high grades on lab skills. And the lab notebook is worth 15%. So it's important that you keep up the lab notebook as you go. Don't try to fill it in at the end. That's impossible the way I've got it set up now, because you can't. If you try to fill it up at the end, you'll never get the labs done, because you can't see the videos until you submit that evidence that you've prepared your lab notebook. Now, there will be a delay, right? So when you submit your lab notebook papers, it may take me a day or two to get to them, grade them, and put the grade in, because until the grade appears in Blackboard, the system will not release the video. Right? So you have to submit it early enough so that I can grade it and you can get access to the video in time for its due date. And I'll show you that also in just a second. Let's see, that's coming up next. Here we go. Okay, so standard format. I call it Zoom tutorial. That's what we're in right now. These are all voluntary. After today, then you show up if you want to. And if you have to show up at a remote without your connection to Blackboard, then you can use this code on your Zoom client, and this passcode will get you in. Now, these are the start dates for each of these exercises. Lab safety, conduct, lab reports, we've talked about that. Wednesday, next Wednesday, is the start date for lab exercise 1. So you need to have submitted before then the evidence that you've prepared your lab notebook. I know that's not much time, but we're kind of running short of time anyway. Trying to squeeze. Believe it or not, I tried to do more than 7 labs in the past, and it was a disaster. So I've reduced the number of labs, primarily because formal reports are required, and formal reports take a lot more effort. Right? So I pared down the number of labs. And these first 2 in the beginning are informal, so they shouldn't take as much effort. Oh, you know, I found an error. No lab notebook entry is required for this one. Right? So in that case, this one should open up right away. I'll check it in Blackboard. When we get in there, we'll be sure that that one's available right now. So you should be able to go to that one. And then once this one is submitted, once Lab 2 is submitted from your lab notebook, then it will open up as I've graded it. But these first 2 are informal. That is, you just fill out the document and any extra stuff that you have to do. I think the first one you have to draw graphs, right? So there's graph paper included. And then, and actually, I think they're built with a point structure in the document, so you know how much each one is worth. And the first one actually has extra credit, I believe. Don't hold me to that yet. We'll look at it and see. And this one, Lab Techniques, that one requires only an informal report. So you fill out the document. But starting with Lab 3, Waters of Constitution and Hydration, That's an actual experiment that needs to be submitted as a formal report. Okay, so these, I used to didn't do this, put the due dates in here, because what I would say is, if a lab exercise starts on this date, when the next lab exercise starts, that's when the one before it is due. But for some reason that confused some students. So over here I put the due date for this one, which you'll see it corresponds with the start date for the next one. And that's the pattern all the way down. Okay. The last one, I have to say the due date because there's nothing after that. So it sits there by itself. Okay, any questions about that? Let's see if there's, you don't get credit for attendance, you just show up. I mean, you just produce the work. Now, this doesn't happen very often, but sometimes students will copy their neighbor's work and submit it as their own. So I've included a document in Blackboard, and I'll show you where it is, on plagiarism. Because most students know what we mean by plagiarism in an English course or a history course or a sociology or psychology course. That's fairly easy to deduce. But how do you know that you're plagiarizing in a science course? Especially if you're working off the same data set. So the whole class is going to be working off the same data set because I did the experiment and you're all watching me. So you got the same data. Reporting that data is not plagiarizing, right? That's the data. That's what you work from. So I've created this plagiarism document to help you understand what I consider plagiarism. Now, if you answer questions and draw conclusions that are wrong or difficult to understand or bring your score down, and they came from you, then that's a valid estimate of how well you understand the subject. But if you copy your neighbors, then you have two possibilities. Either your neighbor is pretty smart and you benefit from that copying, or your neighbor is about your level of intelligence and understanding or worse, and then you could both fail. Right? So plagiarism is a dangerous game to play. Now, that's not to discourage collaboration. You can discuss the experiment with somebody. You know, if you're trying to understand a concept and you think one of the other classmates explains it better than I do, then by all means, talk amongst yourselves. But when you generate the report, you need to put it in your own words. You need to do your own calculations. You need to report it as your work. Okay. You've already seen that before. That's tutorial sessions that we're in right now. Okay, and there are no appendices. Okay, so now we can go to Blackboard, and we've got 15 or 20 minutes left. We should be able to do that. Oh, let's see. Stop share. There we go. Now let me share Blackboard. Which is right here, I think. Let's see. Okay, there. I've already gone into Blackboard, so let me open it up. There it is. So here's the Blackboard course. And it's got the similar stuff you've seen before there, everything down through the course schedule. That's, we've discussed that earlier. There's another thing on Office 365. I've got a safety folder here, right? So that gives you safety rules. If you read those, I don't have a graded exercise on safety. I would have something if we were face-to-face. But what you would do with these safety rules and this document, laboratory safety, is to use that as a guide to look for safety indicators in the method when you're putting it in your lab notebook. Okay, so really all you have to do is just read through that and hopefully remember what you read when you're building the experiment in your lab notebook. Okay, so here are the lab exercises. Right? This is your first lab notebook check. So when you fill in the front cover and you number all your pages and you create your table of contents, then you go in and you scan or photograph that middle page, last page. This is where you submit it right here. Okay, so you just open that up and there's a place to submit your work right there. And I've also included some things in here. I've told you in here exactly what I've told you about this before. So it's a reminder. What am I looking for? For this first notebook check, that's what I'm looking for. I don't even know if you need the where do I drop my lab report documents, but it's there if you need it. Okay, this was the first day in the fall semester. That's a video. You can look at it if you want. And then here are the exercises, each one at a time. Since I'm showing you the instructor view, you see here's the exercise that I had to do away with because the free version of Microsoft Office doesn't have enough functionality for you to complete that. So if you don't have the full version, you can't do this lab. So I just threw it out. And I've inserted this one to take its place. So here you have the video. And let's see, let me be sure. I'm going to go in as a student and be sure that video is showing. Lab exercises and exercise 1. Yes, okay. So I haven't put any restrictions on this video because you don't have to put it into your lab notebook. All right, you just watch the video, take the exercise, which is here. Right, it's going to look like this as soon as it loads. It's a pretty long one. Got lots of information. If you've never drawn a graph on a Cartesian system, and you've never had any experience with it, this will tell you what all of those, what the axes represent to a scientist, what they mean to a scientist, not to a mathematician, to a scientist. Right? So, for instance, the x-axis is where you put the independent variable. These things change because I, as the researcher, made them change. That's what goes on the x-axis. The y-axis is the response. So when I make these changes, what does it do? Well, it does this. And each of these points, of course, still mean two numbers, the x and y. XY means that dot. Different XY means that dot. Okay? And more description. So this is going to take some time to read through it. Tells you how to calculate the slope of a line, right? The change in y over the change in x, right? That's what the delta means. So how do you determine the change? Well, let's see, if you go back up to this one, you say, okay, if you're going from this point to that point, how much did it change in y? Well, it changed from this value to that value. That's your change in y. And for x, it changed from this value to that value. That's your change in x. If you divide the delta y by the delta x, you get the slope of that straight line. Okay? I hope you've seen this before, at least from a mathematical perspective. And then when you write the line, when you write the expression, for a straight line. Let's see. Oh, here it is. Remember this? Right. You write the in the dependent variable, whatever it happens to be, and then the slope of the line times the independent variable plus the y-intercept. Okay, y equals mx plus b. That's the standard format for a straight line. So if you know the slope and you know the y-intercept, then you can write a mathematical expression of a straight line. Now, in sciences, it may be something like, oh, I don't know, I'll probably mess it up. But you have some variable here. Oh, well, let's go back to that, this one here. The x value would be temperature. So instead of x, you would write T there. And then this would be volume, right? So instead of that and that, you would write V equals the slope times T plus whatever the y-intercept is, right? So that's what your straight line would look like in mathematical form. Okay, so once you got through that, then there are a series of questions. Well, this describes how do you make a straight line out of a curved line? Because scientists, if there's one thing they hate, it's curves. Curves are more difficult to describe mathematically than straight lines. Straight lines are easy to describe and use. So whenever we can make a straight line out of a data set, we do it. Sometimes you have to transform a value. Like for this one, pressure is the same on these two axes, but here it's the straight volume value against pressure. This is actually Boyle's law, pressure versus volume. But if we make this transformation and take the volume and take the inverse of it, and then we take the inverse values and plot them against pressure, you get a straight line. Now, when we get to our discussion on gases, I'll elaborate, right? But for now, straight lines can be made sometimes by transforming variables. And let's see. So this is a complex curve. It's a titration curve. So volume of base added here and the pH, or the acidity of the solution, it goes like that. And that's standard. They all do that. This one's called a broken line. So it's straight until you get to here, and then all of a sudden it goes boom, and there. But it doesn't do that. It does that because we drew a line through it. It actually goes up here and then sort of starts fast, and then it goes real fast, and then it starts to slow down, and then it straightens out. Okay. So in order to describe this curve, we generate two lines. Now, that one and this one, I think, are in the extra credit section. So let me find out if that's true. Okay, I do have a bonus section. Okay, so those complex lines and graphics are in the bonus section, and you can tackle them if you want to. You don't have to do them. But the required points are worth 78. So what that means is when I add up the points, I divide them by 78. If you get more points by going into the bonus section, and that adds on top, and say you did a perfect required section, 78 over 78, but then you get some bonus points. Add those, it's more than 78, so you could get more than 100%. Okay. So this tells you, this first page is easy, it's just definitions. So you can go back to the document and say, what are the answer? And then what 5 items must you consider when selecting the size and range of a scale units for an XY axis? So how are you going to draw a graph? So you need to look at the video because I describe it. You know, what do you need to know to draw the best possible graph with your data? Things like you want your data to cover the maximum amount of size of the sheet of paper. Because if you squish it into a little bitty graph, it's going to be hard for your readers to tell what's going on, and you want clarity. So when you're generating a formal lab report, or when you're generating a graph, or when you're disseminating information, in science we call it publishing your work, you want to make it as understandable as possible to the readers. Right? So that's why sometimes I suggest take your formal report and give it to somebody and let them read it. You know, does it make any sense? Even if they don't have a scientific background, it should flow. They may not understand everything, but at least it doesn't confuse them on the structure. Well, similarly for graphs. All right, why do we do graphs? Graphs allow us to understand the results of the experiment better. If they don't do that, then you don't need one. Sometimes just a table of numbers will do, if there's just a few of them. But if there are a lot of numbers and they're complicated, then sometimes graphics, or we call them figures in a publication, will allow you to explain your conclusions better. So you want clarity. And one of the things is make it fit the size of the graph that's available. Then with a sheet of paper, do you want it to be portrait or landscape? You know, sometimes you need a long axis for one variable and short axis for the other one. So you would do it landscape. Then what units are you going to put on the axes? You know, how far do they go? They go all the way to the end? Well, if you don't choose them right, they'll stop here, and then you got all that empty space. You want to spread them out, but you want to make it convenient. So when you have a grid like this, maybe the major tick marks will be in tens. You have 10 units here, 10 units here, 10 units here. If that's the case, then you want the tick marks in between, the minor tick marks, to be a reasonable division of those tens. Say if you have 5, then each one's worth 2. Or if you happen to have 10 tick marks, each one's worth 1. But if you only have 3 tick marks, then each one's worth 3.33333. That's a little harder to use when you're graphing here. So you want to make them whole numbers evens. Right? So those are the various things, and the video helps explain that too. Then there are other questions to answer. You got to graph these data, right? And that's what these 10 points are for. And you'll do that on graph paper that's provided back here. Here we go. There's graph paper. There's more graph paper. The reason I skipped a line is so that the graph paper, you can remove it. Once you print it, you can remove it, and you're not removing something else along with it. Right? So it's a separate sheet of graph paper because I put those spaces in there. There's another one, and there's probably several more. There you go. So there's your graph paper, and you want to submit those. Of course, they're going to be hand-drawn, so you got to photograph them. And the extra credit starts right here. Right? So up to that point is required. Beyond that point is if you want to. Okay, any questions about that? Got 3 minutes to go. So we don't have to stop there. I mean, if you want to stick around, I'll keep, if I think there's something else that needs to be covered, I'll just keep talking. And if you have to go, that's fine. Okay, so that's the first one. And that's what the student sees. I'm still in student preview. So let's go back and see exercise 2, lab techniques. Video exercise. Okay. So in this one, the video's not showing because this one requires for you to submit in this place right here the lab notebook pages that pertain to that exercise. And all you have to do is click on it, it opens up, and there's a place for you to attach the file. Notice there are no extra files up here for you to download because you're creating them. So once you create the file or files, you could submit them right here because it'll accept more than one file. If for some reason you can't figure out how to make a PDF file out of your images, then just submit all your images here. You can submit multiple images. And then what I'll do is I'll take those images, I'll compile them into a PDF file because I have the facility to do that. And then I'll grade them and give you a grade. And I hope, if I have time, I hope to submit my response. In other words, I'll take those pages and mark them up and send them back to you. But first thing I want to do is get the grade and put the grade into Blackboard, right? So that the video will open up because I don't want any delays there. And then later, if I can get the time, I'll submit the pages. I want to do that as much as possible so that you know what's going on. I mean, if you make a mistake, you want to know what it is so you can correct it, right? Our whole point here is to get better at what we're doing. Okay, so that's lab exercise 2, and we have the base document here, right? You can open that up later. And then the fall exercise 2. Oh, this accompanies the video. Let me see what that is. It's a document. Oh, okay. So that may be some of the data that's contained in the video. You better check it though, because I'm not sure. If these values don't coincide with what I'm talking about in the video, then you want to ignore it, okay? My point, I'm not trying to mislead you, it just, I may have made a mistake. But ideally, that will correspond to the video that pops up later. Okay. So then we'll have Boyle's Law, we'll have these. Let me go down to say, let's just go to the last one. I'm running over, but okay, there's the document. And there's a place to submit your lab notebook pages. And let's see what the document looks like. Okay, properties of gases. Oh, determination of the molar mass of a volatile liquid. Okay, I wish you could do this one in person because it's fun. But okay, this one has some pre-lab questions. So I'm expecting to see pre-lab questions for this one in your submitted pages. Then you have objectives, materials, right? All those, procedure. You're going to, the procedure will have you calculate the molar mass of a gas, of a volatile liquid by this method. And then you're going to take the calculated molar mass and compare it to these guys. It's like multiple choice. Which one does it fit closest to, right? And then identify that in your report. I got some special notes here, right? Then post-lab questions, those come later. Let's see. Okay. I was just checking to see if there was anything else of interest there. All right, so what else are we going to see here? Lab exercises, extended character set. I'll get to that in just a minute. Lab notebook and reports, how to. Okay, so these are going to show you, this is a lab report instructions. Right? Give you guidance in how to set up the report. This is a sample rubric. Actually, we don't need this one because we're not going to do that experiment. So ignore that one. For Excel, for chemistry, I should have graded that one out, and I will do it in just a second. So this rubric shows you what I'm looking for. Right? So you get 12 points if you're perfect. So do you have all the sections in the report that I'm expecting to see? Plus a little extra. That's how you get 12 points. If you're missing 3 sections in your report or more, you get 0 points. All right, spelling and punctuation, these are easy points. Use your spell checker. Read it a couple of times. Have somebody else read it for proofing. Grammar. Okay, here's where you need that past tense. And it's third person, passive past tense. Third person is what? It's not me and it's not you. It's it or something else. Third person. Passive. Something was done. And past tense. Okay. Oh. Sorry, delivery. Okay, so this is where students really mess up and they never seem to learn, right? I can mark it in all the red ink I want, and they just keep coming back. And I think the reason is because they're pressed for time and they just copy the method out of the hard copy. You know, and if I see that, if I see grammar and wording that indicate that you just copied the procedure out of the method, then 0 points. If you put it in your own words, but you just use the wrong tense, then okay, 6 points. Procedures. Do you have the procedures listed and numbered, right? And the various descriptions there. How is the data presented? You know, is it sloppy? Is it handwritten? Is it typed? Right? You should type the whole thing. The only time I allow hand-drawn things is if you don't have access to a program, a computer program, that will allow you to create a pretty computer-generated graph. If you have to draw it by hand, and say you draw it in your lab notebook, and then you take a picture of it and insert it into your report, that's okay. I accept those. But everything else needs to be typed, printed, because I don't want to have to struggle reading handwriting. So how's your data? Does your data look professional? You know, say if you're going to generate a table, you may have volume up here. You may have pressure up here. Well, the volume might be in milliliters. Pressure might be in atmospheres. That's the only time you have to write the units of measure is in the header. And then down here just comes the numbers. You know, maybe you did the experiment 4 times, or you changed something and it changed these values, right? So it might be well, if you want to know what professional looks like, just go online and Google some scientific articles and look at the way they present their data. That'll give you an idea of what's acceptable as a professional looking, what professional looking data is like. Let's go, you know, we may already have an example. Hold on a second. We'll come back to that. No, we're in the right place. We got 2 examples here, Boyle's Law and waters of concentration and hydration. Let's look at this one. Let's see what this student got. Okay, it's kind of on its side. 96%, that's not bad. But their data was well, it was sort of professional looking, but it had some problems. So I sort of split the difference. All right, so if we go down and look at their data, oh, that's why. They made mistakes, right? That's it. But Here's the other rule. When you draw a graph, a figure, or you have a table of information, whichever the case may be, they have to stand alone. In other words, they have a title, they have the axes properly labeled with units of measure and drawn in, whatever happens to be, or with the table, it's got a title. If it needs some extra explanation, it may have subtitles at the bottom of the graph, of the table, but it has to stand alone. If you extract that out, you should be able to tell from that information what's going on. Okay? So tables and figures do not depend on anything else for at least a rudimentary explanation of what they are. Now, more details may be necessary, right? And that's what the methods part of the publication is for, and that's what the results and discussion is for. But the table and the figure need to stand alone. So when I look at your tables, when I look at your figures, in anything you do, I'm looking for those items. Does it have a title? Is everything else identified correctly? You know, does it stand alone? Okay. So in the Boyle's Law, there's another one. Here's what's plagiarism in a lab report. Right? So you can read that. If you have Microsoft Word full version, then this can come in handy. This tells you how to enable the equation editor, because when you're typing out your report, you may need to put in a chemical equation, something like that. And this will help you do that. Okay, what else? Let's see. Those are extra things that are not as important. There's one thing that extended character set. Okay. This is a table. And if you have a Windows-based computer, these two sections over here from this place over are for Windows-based. If you have a Mac, these symbols might be useful. Now, why did I build this? Well, keyboards don't have these symbols built in. Right? Now, you can go to, let's see, what's it called? Shoot. Character map. You can go to the character map and find any of these characters you want. Click on them, copy, and paste them. But that takes 4 or 5 steps. If you're in a hurry and your train of thought is running, you need a way to insert these symbols when necessary quickly. So these are extended character sets. These are Windows-based. These are DOS-based. You may not remember DOS. That was a precursor to Windows. But sometimes they still work. So how do you do them? Well, if you need, say, let's say you need a symbol, and I know it's kind of small, but let's say you need a symbol that looks like delta, right? You need a delta Y, delta X, delta H, something delta. Then you can type in, hold down the Alt key right here. See that Alt? Hold down the Alt key, and in the number pad, I hope your computer has a number pad on it, type in this sequence of numbers, 0, 9, 1, 6, and then release them both. And you should get the delta pop up right there on your page. If that doesn't work, you can try the DOSes. And I think, is there a delta for the DOSes? Let's see. No, I didn't find one for the DOSes. So if that doesn't work, you got to go to the character map. Or you can go to the font. And sometimes you can get a font out of it. But this is meant to be a quick way to get the characters that you need. Okay, I think that's, to quote a famous actor, Forrest Gump, that's all I had to say about that. And of course, any problems, I'm a click or a phone call away. Any questions? All right. So I guess the first thing you have to do now is go locate one of these. They disappear from the shelves. And if there was some way, if I could figure some way to make them available to you, I would. But I could only think of mailing them to you, and it costs more to mail them than it would to buy one. So if you have any difficulty, let me know, and maybe we can figure something out. Okay? I'll post this video in CHEM103 Blackboard as soon as it's I can, as soon as it's processable. Let's see, exit the preview. Yes, and stop the share. Yes, there we go. Okay,